All right, today we are diving into something that's, well, a little scary, but also super fascinating. We're talking about a new kind of quantum defense that's being built to protect our most personal data, our health info. It's a huge deal, so let's jump right in.
You know that smartwatch on your wrist or that fitness tracker? We rely on them, right? For our heart rate, stress levels, how well we slept. We literally make health decisions based on what they tell us. But what if they're lying? What if that data is being messed with before you even see it? And this isn't just some sci-fi plot. Researchers at the University of Tennessee are telling us this is a real present danger. If someone tampers with that data stream from your sensors, it could lead to a totally wrong diagnosis. And think about that. In the worst case scenario, that could lead to some really dangerous, even life-threatening medical advice. I mean, this is a hack with truly disastrous consequences. Okay, so how would a hacker even pull this off? Well, the study breaks it down into two main attack methods. Think of it like a hacker's toolkit. They've got two very different weapons they can use. First up, you've got something called data poisoning. This is pretty much the brute force method. The most common way they do this is called label flipping. So imagine the AI is in training, learning what's what. The hacker gets in there and just starts switching the tags. They'll take a totally normal, healthy heartbeat and slap a label on it that says abnormal. They're basically poisoning the well, teaching the AI all the wrong things right from the start. All right, the second weapon is way, way sneakier. It's called adversarial perturbation. This isn't brute force, this is subtle deception. What the hacker does is add these tiny, almost invisible changes, like a little bit of static or noise, to the data. These changes are so small you'd never notice them. They don't even change the overall stats, but they're brilliantly engineered to trick the AI, to make it see something that isn't there and make a huge mistake. So there you have it. It's basically the sledgehammer versus the scalpel. Data poisoning is the loud, messy attack that messes up the data from the source. Adversarial perturbation, though, that's a silent, surgical strike. It uses invisible noise to fool an AI that's already been perfectly trained. Okay, so we've met the villains. Now, who are the heroes? Who's going to protect our data? Well, in this corner, we have the reigning champ, classical AI or machine learning. And in the other corner, we've got the challenger, the powerful newcomer with what feels like superpowers, quantum machine learning. So the big idea in this research is to use quantum machine learning, QML for short, as this new kind of digital super detective. You see, because of all the weird and wonderful rules of quantum computing, QML can spot these incredibly complex patterns and connections in data that are just completely invisible to our normal classical AI. So how does this quantum detective actually work? It's basically a three-step process. First, they take all that raw health data and clean it up, zeroing in on the most important bits. Step 2, and this is where the quantum magic happens. They encode that data into qubits, which gives it this unique, super complex quantum feature map, or signature. Then, for the final step, they use a more traditional AI to study that quantum map, teaching it to know the difference between the good guys, the clean data, and any imposters. All right, so the scientists built their quantum detective. They took a bunch of real-world health data and threw both types of attacks at it. The stage was set for a showdown. So, the big question is, how did this new quantum approach stack up against the classic AI? And the results are, well, they're really interesting. If you look at the data here from a stress level data set, you can see two totally different stories playing out. Against that brute force data poisoning attack, the quantum model is the undisputed champ. But then you look at that second row, against the sneaky perturbation attack, and whoa, the story flips completely. Yeah, check this out. Against that brute force attack, the quantum model was an absolute knockout. It spotted the bad data over 95% of the time. That is a huge jump compared to the classical model. The quantum advantage here is just, it's undeniable. It's not even close. But then comes the twist. When it went up against that subtle, stealthy attack, the quantum model's performance just tanked. It drops to under 46% accuracy. That's literally worse than a coin flip. The classical model did a little better, but honestly, both of them got their butts kicked. It just goes to show how seriously dangerous this kind of attack is. And you gotta respect the researchers here, they don't pull any punches. They say it straight up in their paper. The performance on this attack is not satisfactory at all. And that kind of honesty is exactly what you want to see in science, right? It's not just about celebrating the wins. It's about being real about the challenges that are still ahead. So What's the takeaway here? What does all this mean for the future of keeping our health data safe?
Okay, let's break it down. What did we learn? 1. Quantum machine learning is a seriously powerful new tool, especially for stopping those simpler brute force data poisoning attacks. 2. Those really sophisticated, subtle attacks, they are still a massive threat to pretty much all AI models, quantum or classical. So yeah, the quantum advantage is a real thing, but it's not a magic silver bullet. Well, not yet anyway. What we're really seeing here is the first move in a whole new kind of technological arms race.
And that leaves us with one last big question to chew on. This research, it's given us a glimpse of a powerful new shield, but it's also shown us an even sharper sword. As our technology gets smarter, the bad guys just get smarter too. So it makes you wonder, this race to protect our most personal, most vital data, can it ever really be won? Or is this a fight that never ends? Something to think about for sure.